Building the gallows outside my cell. I got 25 minutes to go. Well, gentlemen, this particular project here is for my Patreon subscriber and also my friend. His name is Ed. And Ed sent this up a long time ago before Patreon was even a thing in my world. And it's been sitting here in a box. I'm out here clanking around going, okay, what do I got to do next? And I picked this box up and opened it up. And I'm like, oh, it's a suite. I can do this relatively quickly. So I opened up the box. Okay. Was talking on the radio without the amp. Parentheses. Don't use the amp that often. I let the antenna do the work. I got a 6-element beam. Skip was getting the best of me. I turned on the Fatboy 200 amp power supply, which is more than enough. Then I made sure that the 2970N, I'm sure it's got a number after, it's just not on the note, was turned down. Flipped the switch on, the Texas Star. Checked SWRs, etc. All good. Keyed up. Opened up my big mouth. Unkeyed, and all the meters said I was still keyed up. So that means it was oscillating for some reason. I proceeded to shut everything down. And then I started to restart. Slow restart radio works. Turned on the Texas Star, nothing. Turned Texas Star off. Radio still working through the Texas Star. Called you today. Described what I seen. And then I told him to send it to me. He goes, smoke-free environment, but I do have pets. That's the reason this is out here, because I just had to suck like a pound of fur out of the thing. It's okay. I got dogs too, dude. They shed. Well, long and the short is he's got these 4 that are blown. The upside is it's got HGs in it. Now this is a Texas Star hot plate. DX 1200. So we ask ourselves in times like these, what do we do next? What do we do next? Well, it's pretty broken. These balance resistors are fried. This one here, that one there. The 10 ohmers are popped like fricka fried, which is no big deal. It's no big deal. So, I mean, we recognize that we're going to have to build some new combiners. We can't get these old combiners anymore. There's web pages out there that say that they have them, and then when you order them, they notify you and refund you back your money that they're out of stock. It is what it is. So we're going to rip this thing apart real quick. There's part of me that wants to test this because it's already effed off. I mean, it's really effed off. And the spattering of combiner fecal matter here that's all over the case is just epic. This here and this here. That's all the paint on this combiner is straight effed right off. And it's been blown all over the inside of the cabinet, so I'm just wondering if there would be any point behind me trying to power this up and seeing if it's going to stay oscillating. These are pretty stable boxes, you guys, and there's usually something exteriorly that causes these to fry, like the one that I just did where the guy literally came to a stop resting against a telecommunication wire and set the drive-thru's internet on fire. I don't know. I'm going to rip it apart. Let's get it all put back together, and then we'll start testing it from there. And if it's oscillating after we get it all put back together, then we'll know. We'll work with it from there. It could be a stuck relay. You know what? I just want to power it up. Let's see what the relays do. Just powering it up, not even having to key it or nothing. Whoa, hey, whoa, sorry guys. Let's just power it up. Let's see what it's doing here. It's not pulling any current. Amp is on. Just wanted to see if the relays would latch as soon as I keyed down, or as soon as I powered it up. Sometimes what happens, very rarely, this transistor will pop, and it will pop in such a fashion that it stays latched. I thought that might be what's going on, but obviously no. Yeah, okay. Hello, 1212. Now we know that this is broken. What we're looking at is this amp gauge over here. What we're looking at is the amp gauge, and we're listening to our relays move. Doesn't seem to be oscillating. It doesn't seem like it's being locked in transmit. So I'll have to see if the problem presents itself after we get 4 new pills put in it. I gotta do a little bit of heart surgery on this because this back one's gonna be a little bit of a pain to get to. This back transistor, I'm gonna have to really do my magic. So, okay, I shall return. Okay, so your job as an amp tech is not to just be an amp tech, right? You got to learn how to read tea leaves. You know the old expression of, we're going to throw some tea leaves in the water and watch how they float, and we're just going to pick a conclusion out of that. I'm looking for what caused this amp to fail. And I just pulled the flybacks out of it. And it's these resistors, okay? And on the end of each flyback is about 1 nanofarad worth of capacitance. This is one of the flybacks out of this section. Something caused this thing to go bad. Well, we're going to use our Atlas LCR. This is an automatic passive component analyzer. This one is, we got longer leads on it, so this is about right. This is the one that was paired with this one that's in the tester. So now let's look at the capacitors that are back here on this back section. Now these little glass caps, they don't break down very often, but when they do, they have horrible effects because it takes and dumps 12 volt directly onto the input. It's 131 nanofarads. This is interesting. So this is our baseline, this is our reference. 139. Now let's look at this one. Right? Let's look at this one. Okay. .3 picofarad. Almost has no capacitance to it whatsoever. I bet you if we put a voltometer on it, it'd show it as completely open. So, what caused this to fail? I still trust these, but we're going to pull these off. We're going to replace them with disc capacitors. Or pardon me. Identify. I'm just going to replace all of these with disc capacitors. I don't trust this. This one's still within spec. But it doesn't matter. That's where our failure point was at. So I know that a high resistance amount of 12 volt current has flown into the bias circuit, and that's what caused this and this to fry. The bias circuit's all tied together as one string. So the 12 volt source that feeds this input transformer and this one are all tied together through this secondary set of wires here. So it goes by a filtering cap, goes through a resistor, goes through an isolation choke, goes to a reference resistor, and then it goes through another isolation choke and then to the input transformer. So we've had 12 volts leak. We've had 12 volts leak from the 12 volt side of the amp through the flyback with 100 ohms worth of dissipation on it, or whatever those are, 75 ohms or whatever they are, worth of dissipation, then back to the input transformer. It kills the transistor, then the transistor goes open. See, normally I can pinpoint this right away, and I'm like, oh, blah, 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 and I knew what caused this, and so I don't feel too bad about loading the transistors back into the amp and putting it all back into one piece, because I know what caused the end result. He's not telling me via his note that there was a high SWR or an overvoltage issue or an overdrive issue. The amp usually tells you the whole story if you know how to read the tea leaves. I guess we're just going to have to go into this one a little bit blind, and maybe the answer will present itself once we get the transistors changed. So the pot thickens. That resistor that's on the tester there is the resistor that comes out of this back corner. It was like I was saying, that's the resistor that controls the bias. Look at this one. It's seen better days. So let's take a look at this one, because we got to replace all of these. Once I have one burn, I don't trust them anymore, right? So visually that looks okay. Let's set that one down. And the goal is to have 1.8 ohm. That one looks okay as well. So, just like this one here looks like it's visually okay, but it is not. 1.8 ohm, and it's reading 360 something ohms. 1.6. .5. So we have a 1.5, a 1.6, a 360 ohm, and one that's refried dog dirt. Interesting. Very interesting. Got all the 10 ohmers out. Let's put some pills back in it, and let's see if we can get it to come back to life. So I got it all rebuilt. And what I mean by rebuilt is the coating, okay, let's start over here. The ferrites are still good even though the wire is effed off. And when the wire gets effed off, the painted coating or the epoxy coating or whatever's on the ferrite gets burnt off. That has nothing to do with how we use the ferrite. Okay, coatings can be applied to the ferrite for multiple different reasons. Usually it has something to do with exposure, chemical, whatever. Who knows? Maybe they bought these little pieces of ferrite and sprayed them with yellow spray paint. I don't know. or red spray paint, or red and yellow, like this one. It's not like we're putting these in nitrogen or some other caustic material and expecting them to do their job. They're sitting in free space, just air, basically. So the output combiner has been rebuilt. This output combiner has been rebuilt. So the primary and then the secondary have been rebuilt. This input has been rebuilt, and it's got 4 new transistors in it. All the blocking caps on the flybacks have been replaced throughout. All the 1.8 ohm balancing resistors for the bias control have also all been replaced. So I go and I put power to it, and I key it for the first time, click. And this goes to pulling 68 amps, and this combiner flared up and got real hot. I immediately reached down and I flipped the amp off, and it killed all 12 volt power to this circuit, and everything calmed down. The amp load fell away on here, and I went, oh, okay. So I go and I clip on my my voltmeter, and I attach here to this bar. The reason we attach here to this bar is because this is where the bias circuit starts. This relay is a switch, right? And it switches 12 volts, passes it down through a trace, and it comes out through these 4 traces here. And then goes out through this bar and then gets distributed off. So I started pulling off one bias section at a time. So I pulled off this board, no, it's not that board. So I disconnected this board, no, it's not that board. Disconnected this board, no, it's not that board. So it means my problem laid here. And what I mean by it wasn't that board is there was 12 volts being applied to the bias circuit all the time. You could tap this relay just right, turn the amp on, and it wouldn't do it. As soon as you keyed it, it went through the cycle motion, there was 12 volts being applied. That is why this box burned up. I'm going to prove it to you definitively here in a second. So then I walked through the whole process of making sure it's not. So like as soon as I lifted this leg off, which controls this relay fires, turns on 12 volts to this circuit. This wire feeds back, it comes to this trace, it goes through the yellow wire, and it attaches to the antenna relay. This is your sense wire that drives this relay, but this is the relay that actually controls the high and low, like on and off. This is what controls 12 volt switch. This is what controls the actual antenna movement, okay? Otherwise, make more RF, not make more RF. All comes from here. As soon as I lifted this out of the way, this relay went to full drive motion. And I went, okay. When I see that happen, what that tells me is that there's something wrong bias circuit post or in a keying transistor. So I proceed to pull this cap, and this diode, and then I pull the keying transistor itself, test all of those components, they test good, I put them back in circuit and I watch it work. This transistor is not firing, so it's getting an erroneous 12 volt signal that is looping back and causing this relay to fire. I'm like, well, what would cause that? 3 days ago, I did a YouTube video on a Sweet 16. This is a Texas Star 1200 hot plate that's been converted over to be a Sweet 16 for the most part. And there was a little piece of shit that was caught in a relay. Now I hope and I pray as I carefully reach in here I don't know if you guys can see that or not, but there's a little ball of shit on the inside of this tab, right down in here. Just the littlest, tiniest ball of shit. And that's all it takes. This happened to me just the other day. Spent a few hours looking at the other one the other day. Here, let's see if I can pry it up from this side. There's the tiniest amount of shit on the inside of that tab, where all I got to do is flick the shit out of there. And we'll be back in business. So, let me flick the shit out of there. See that little tiny ball? You see that? A little tiny nub of shit. See that right there? Right at the edge of the razor blade? No, that's not the razor blade. There's a little ball of solder. Or something. There, I just flicked it out, just like that. Nope, guess not, it's still there. But I actually caught it. I got it on film. I wanted you guys to be able to see what happened. Now I clean this off, I bet you things are gonna go well. So let's see, output. And we're not even looking over at the watt meter. The only thing we're looking at is this voltmeter. We're going to cycle this a couple times. Now, no RF is going into the amplifier because this relay is disconnected. All we're physically looking at now, turn the amp on, is to see if this relay moves through its function arc. And we have 12 volts kick on and then shut off. So we're going to shut the amplifier off. Hello. See, we can easily talk through the box. Hello, 1 2 1 2 1 2. Okay. On, off. On 12 volts, off. Hello, 1 2. The amp is not making any power. I just want to make sure that the bias is shutting off. It would not do this before. It wouldn't read 12 volts and then shut off. Read 12 volts and stay latched because that little tiny ball was causing that contacts to stay welded. So when the relay would come back into the relaxed position, it was now feeding voltage negatively back into the circuit. Now, is that all that's wrong with this box? Don't know. Are we going to find out here in just a couple minutes? We sure are. It could still have some other caps that are bad, like some of the capacitors on those back 4 transistors might have fallen out of tolerance. And once we put power to this thing, it starts to oscillate, like this cap or that cap, or this cap or this cap. That could have been affected by our catastrophic meltdown. As soon as we put power to this, it's going to start to oscillate. As in, like, I'm going to shut this down, disconnect the 12 volt, and I'm going to go back in here and hook all this stuff back up, and then we're going to start testing that. Stages. But I can't believe I've had 2 in less than a week of the same failure, which in itself is incredibly rare. Man, it is. It's just a ball trip, is what that is. To have 2 of those things fail in the same way, that is a trip. Okay, now to test that the bias circuit's running properly. Without letting any RF hit the circuit, we're just going to see what we have for bleed down voltage. And what we're looking for is, remember, the transistors are not underneath the load, they're not operating. So this isn't a definitive form of measurement, nor is this the proper way to measure this. We'd measure this with current. How much current is the circuit pulling, but we cannot test that unless the circuit is completely on and running. So 5.87, 0.06, or 0.606, 0.586, 0.586, 0.608. So they're all within about 1.3%, 1.4% of each other, which I feel comfortable with. I'm okay with that. It's one of them days. Sorry about that, guys. I just pulled my mic off. Hold on. It's one of them days, no matter what I touch, it just... shit's gonna get snagged. Nothing's gonna go right. Okay, so... that is an interesting result. Okay. Let's go figure that out. Well, there definitely shouldn't be 12 volt there. So in my haste to hook everything back up, I hooked up a wire wrong. So everything is fixed now. Now we're going to start looking at the watt meter. We're going to look at our amp meter. But we're going to look down here and we're going to see that the output combiner is quiet. That's combiner is quiet. That combiner is quiet, and the only thing getting hot in here is that bias resistor, that bias resistor, that bias resistor, and that bias resistor, just the way it's supposed to. I had to redo this splitter because it was boogered off. And it was causing this combiner to get really hot. So only one of these sections was firing, but it wasn't with enough inductor. So I rebuilt this, everything's smoothed out. Okay, last thing I want to check is how much current it's pulling on each one of the input transformers, or check my voltage on the input transformers, that is. Blah, 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 blah. All right. 4.86, 4.75, 4.94, 4.72. As soon as we modulate it, that number drops and it evens out. So it makes me happy. They're all below 0.5 volt, which is good. Means we're deep, deep, deep into Class B operation. All right. So with the amp off, let's go over here and look at what we got going on. 1,000 watt, 1,000 watt. Peak, average. Hello, audio. That's all we're putting into it for drive, boys and girls. Let's turn the amp on. Hello, audio. Hello. Making 600 peak. Hello. About 210 bird. Hello. 1, 2. Pulling 78 amps. Let's reach down here. If I can get down here, I can't. And we'll turn on the bench power supply. So we'll stop running off the lead acid batteries underneath the bench. We'll start coming up in power. Up we come. There we go. Okay. Now let's rerun that same test. Hello. About 25 watts worth of power. Hello. Hello. About 950 peak. I'll take that as a win. Should never shut this off. Output combiner is quiet. Splitter is quiet. That splitter is quiet. What I'm looking for is heat. If I have no heat in any of these circuits, that tells me that these two boards are in balance, these two boards are in balance, and this is telling me that this section and this section are in balance with each other. And there's no electrical resistance taking place going out of the amplifier. I can see that with the watt meter. Hello, 1 2 1 2. Let's mosey on up here real quick. Hello, about a half a watt, not too bad. For a Texas Star, that's not too bad. Hello, 1 2. Hello, 1 2 1 2 1 2 1 2. So let's disconnect the 2950. We'll go to the derail built spectrally pure 955. And this will make that 1000-watt slug disappear into the corner. Okay, we'll turn the amp off. Hello, audio. About 150, 140 watts worth of drive. Hello, audio. Hello. Now, let's see, do I got the variable bird knob all the way down? Hello. About 500 bird. No big deal. Let's go up to 2x. So that little hash mark right there is now 1000, 12, 14, 16, so on. You should get about 14 plus out of this. Hello. Hello, 1 2. Hello, 1 2. It's perfect. Once again, now that we've turned up our power quite a bit, that splitter is nice and quiet. The final combiner, ice cold. This splitter, nice and quiet. So, call this a win, and I am out of here. Hello, 1 2. Hello, 1 2. Hello, 1 2. 1 1 1 1 1 1 1 1. Hello, 1 1. Hello, 1 1. Hello, 1 1. Hello, 1 1. Everything's back to 0. Everything's off. I'm going to call this victory, and I'm going to say we're done. Well, Mr. Ed, you're done, buddy. It's a combination of a lot of things failing in here. This amp was just having a bad hair day. That's all there is to it, Ed. But the primary thing was the problem in the relay, which there's nothing I could have done to test for that until we have the problem, so I don't know. The relay, the capacitor. I'll call you on the phone. Gentlemen, my name is BBI. That's my phone number. You would be surprised how many times a day people come to my group and go, how do I get a hold of BBI? And it's either an attention-getting thing, or they honestly don't think to look that it's also on my webpage, www.bbiamps. It's on my Facebook profile, my Instagram profile, my Twitter profile. It's, don't have Snapchat. Ugh, thank God. Or Google. But gentlemen, I want to say thanks. Just over here working through these one amplifier at a time the best that I can. I got a big old pile of stuff left to go. I got some really fun projects. I'm currently working on in the background, which none of you guys have got to see yet, but a 4-tube Heath kit, which is going to be freaking dope when it's done. The faceplate for it's so cool. I can't say anything more than that, but lots and lots of little burned up wires replaced, lots and lots of bad caps replaced. She's a running. Buddy, it's on its way back to you. Gentlemen, I thank every single one of you. Shout to Siglant, Excess Power, MechMan. Bird, Coaxial Dynamics, all of you, and my Patreons. Please feel free to come over and kick a little bit of love and support if you feel it's necessary, like I've ever done anything to help you, or you've ever learned anything from me and you want to see this dog and pony show continue. Come help. I'll see you. Click, click.